In this video, we'll learn how to find the limits of this type. Limit x approaching a, x to the power n minus a to the power n divided by x minus a. They're easy to spot. In the numerator, you have nth powers, and in the denominator, you don't have the powers. So what's the limit? That's equal to n times a to the power n minus 1. Let's prove this. Interestingly, x to the power n minus a to the power n has a factor x minus a. That's always the case. So x to the power n minus a to the power n is equal to x minus a times something. This is a factor. And what's that something? Well, that's equal to x to the power n minus 1 plus x to the power n minus 2a plus x to the power n minus 3a square, and so on till a to the power n minus 1. The powers of x decrease and the powers of a increase. So if you multiply these two, you will get x to the power n minus a to the power n. Now, we're looking for x to the power n minus a to the power n divided by x minus a. So let's divide that. When you divide both sides by x minus a, you'll get this thing on the right side. Now for the limit, we have x approaching a. Now when x approaches a, because we don't have anything in the denominator here, we can directly substitute x by a. So plugging in a wherever we have x, this is what we get. A to the power n minus 1 plus a to the power n minus 2 times a plus a to the power n minus 3 times a square, and so on to a to the power n minus 1. And how many terms do we have? Well, we have powers from a to the power 0 to a to the power n minus 1. So from 0 to n minus 1, we have n terms. N minus 1 plus 1, that's n terms. This means this will have n terms. And all of these terms have the power of a, that's n minus 1. Here we have n minus 1. Here we have n minus 2 plus 1, that's n minus 1. Here we have n minus 3 plus 2, that's again n minus 1. So all these terms are same. We have n terms, and each of them is equal to a to the power n minus 1. So what's the answer? Summing all of this up, we get n times a to the power n minus 1. So when x approaches a, x to the power n minus a to the power n by x minus a, this thing approaches n times a to the power n minus 1. Let's practice this. Here's the problem. X approaches 1. We have to find the limit for x to the power 15 minus 1 by x minus 1. Pause the video, think about it. Okay, let's do this together. So n here is 15 and a here is 1. So we have n times, that's 15 times a, that's 1 to the power n minus 1. That's 15 minus 1. Any power of 1 is 1, so we have 15 as the answer. Let's take one more. Limit x approaches 1, x to the power 15 minus 1 by x to the power 10 minus 1. How are we going to solve this one? Think about it. Okay. Now to use the formula, we need this form. X to the power n minus a to the power n by x minus a. We have the powers, we have the numerators, but we don't have the denominators. So let's make that happen. Let's multiply and divide by x minus 1. This is what we get. Limit x approaches 1, x to the power 15 minus 1 by x minus 1. This one can take one of them. And you can have x minus 1 divided by x to the power 10 minus 1. This second one will be taken up by x to the power 10 minus 1. Now let's flip this. This is limit x approaches 1, this divided by this. Now we can split the limits. We have limit x approaches 1, this divided by limit x approaches 1, this. So we have two problems. In the first one, n is 15, and the second one, n is 10. The answer to the first one, we've already seen, that's 15. And the answer to the second one, that's going to be 10. So together, the answer for this problem is 15 by 10, that's 1.5. That's the limit in this case. Now, good thing for us is that you can have non-integral values of n as well. This works for all rational values of n. The condition is that this a should be positive. Whenever we have a positive, n can have all rational values. Let's take an example. Limit x approaches 1, x to the power half minus 1 to the power half by x minus 1. Now here n is not an integer, n is half, but we can still apply this formula. This becomes half times 1 to the power half minus 1, n times a to the power n minus 1. Simplifying this, we get half times 1 to the power minus half, that's still 1, so that's going to be half. Let's apply this. Here's the problem. Limit x approaches 0, square root of 1 plus x minus 1 divided by x. Find this limit. Pause the video, give this a try. Okay, let's do this together. We need something to the power something minus something to the power something divided by the difference. We don't have a difference here, but we know that 1 plus x has a power of half. So the clue here is we can substitute 1 plus x by something else. Let's replace 1 plus x by y. This makes x equal to y minus 1. Now replace x by y minus 1 throughout. Let's see what we get. We have limit x approaches 0. Here we have limit y minus 1 approaches 0. X becomes y minus 1. In the numerator we have square root of 1 plus x. That's going to be y. And in the denominator we have x. That's going to be y minus 1. And this looks more familiar. Let's rearrange the limits. We have limit y approaches 1, because when y minus 1 is approaching 0, y is approaching 1. In the numerator we have root y minus 1. In the denominator we have y minus 1. So the power here is hidden and actually is equal to half, because this is y to the power half and this is 1 to the power half. So we can apply our formula. We can say that this limit is equal to half times a to the power n minus 1. That's 1 to the power half minus 1. This is going to be equal to half.